Alrighty. Well, we can go ahead and get started with just a couple quick announcements. And hopefully by that time, I think Chris and Sina and maybe Philip can join as well. Uh, as always, it's been a big week for DeSci Labs, and it's been exciting to see. So for starters, for those of you who may or may not have seen, we just posted the most recent update to DeSci Nodes on the announcement channel. We made a couple changes, mostly based on alpha tester feedback. So thank you to everyone who has given the time to actually go in and help us look through the platform and try to find bugs. For starters, if you want to go into a node, you now go in the default edit mode as opposed to the default preview mode. You have the ability to continue annotating. Whenever you make one annotation, there's a little box that you can click at the bottom that allows you to add multiple. One of the biggest pain points has been PDF uploads through DOIs. So now users can directly upload PDFs from their computer. No DOI or PDF link necessary. We would ask you to use caution when you're uploading information, as copyrights do apply on this system. And we want to make sure that we're not putting ourselves in the line of fire. So please do not upload anything that is potentially infringement on existing copyright. Based on feedback, we've got tooltips in the platform where when you hover your mouse over an icon, you get a short little description. We changed a little bit of the UI, font sizes, things along those lines, and are excited to get feedback on that. So anyone who's an alpha tester that's in this call, if you could take a little bit of time and just look through some of the changes that have been made and provide feedback in the product channels, as always, that would be incredible and greatly appreciated. Thanks to everyone for your time in making that happen. So a couple other quick announcements. Been a busy week in terms of presentations. ETHCC just happened, and our very own Matteo presented his DeSci node live to a group of DeSci community members, which was really exciting to see. We actually will be using some of the film from that on our social media in the near future. Philip gave a talk on impact certificates, which has just been posted on our YouTube about 15 minutes ago. So if you want to learn more about the exact way that we're thinking about impact certificates, please go take a look. It's posted on the, I believe it's called DeSci Labs YouTube channel under feeds. Chris gave a talk at Research Hub all around open verifiability. As soon as we get the recording for that, we will make sure to let you know. In the meantime, a little bit of background noise. Yeah, as soon as we get that posted, I gave a talk around reconnecting the, oh, good to know, Sina. Around reconnecting science to the general public. So we'll be posting that as well. And then finally, Juan Benet, the founder of both IPFS and Protocol Labs, actually gave us a direct shout out in his ETHCC talk on DeSci. So lots of things happening, moving very fast, and it's quite exciting to see. Thank you to everyone who has continued to support us on social media and who is continuing to be active in the Discord as a community member. So with that being said, we're going to go ahead and transfer to the meat of the community call, which is going to be Matteo walking us through the DeSci node that he has created. So Matteo, can you go ahead and share your screen and take it away?
Yep, thanks. So let's see. What about, do you see?
I'm watching a stream. Here we go.
Yeah, okay, great. So yeah, I guess I can avoid talking too much about how the node works, right? People know, or should I explain a bit how the paper is related to all metadata? I don't know, Eric, please give me a feedback on this. Or I can go technical right away and present the work as if it was a proper slide and use the power of the node. Okay. So yeah.
One thing that we would love to hear is a little bit more about your experience with DeSci nodes and how.
Yes. Yeah, no, yeah, I mean, related to what you said, it's really interesting the potential that there is in generalizing the the unit of knowledge in scientific works, and DeSci Nodes, already as they are a really good result. I think there can be even deeper integration. We discussed this with Carla and other people on Saturday. It would be really interesting to integrate scripts generating figures with the backhand, so the source code of the documents, like LaTeX, for example, and to be able to have something like a GitHub action that's gonna update the document and the figures in it together with the update of the code. But I think the node that's already online is going in that direction, so it's really exciting already to play with it as it is. One thing that I just figured that while we're presenting, turning on my laptop, is that before you existed, I started doing science using YouTube. I mean, maybe many people do this already, but I have a YouTube channel that, sorry for the spam, but I just want to underline that it's interesting to, for example, connect this interview I did with the guy that inspired the work. And okay, it's not loading, but okay. And here there's the actual presentation of the work. Yeah, okay, that's loading. So the interview that inspired it, and then the proper presentation of the conference in celestial mechanics this June. I guess the node, I'm not sure if I can link YouTube videos here, but maybe I can. No, I cannot, but it could be interesting to also be able to. I mean, I already did it here, for example. I don't remember where. Yeah, here. It's linked in the Markdown script for the note. So yeah, I don't know why. But yeah, I guess it would be cool to have a unit of knowledge that also incorporates videos, animations, yeah, audio, and different kinds of sensorial inputs, whatever you can think of. But yeah, having said that, the node is made of, this node I'm showing you is based on a work represented at a conference in celestial mechanics, and it's based on some notes I made on the slides we used for the presentation of that work, and on the code that was not presented there, but that was made available on GitHub just when I was working on the node. So you can see here there's repo, there's the README, of course, and then, which is just a few notes, and then mainly there's this interesting, I guess, it's a generalization of existing scripts that perform some analysis in stochastic calculus in Python, and then all the actual computation are done in Julia. And you can see that, yeah, the code is you can see the code. One thing I noticed is this one. If you see, I was working on it and I saw that Julia allows you to have weird characters, not just letters and numbers, but also I think this is a Greek letter that in GitHub renders, and here it doesn't. But okay, it's not a big thing. But yeah, so you can see everything as you would see it in GitHub, and if you click here, you can download the code and you can take a look. Going into the actual work, the presentation is about generalizing celestial mechanics dynamical systems using a stochastic description. And so we start from some analysis of what the three-body problem is, which is a famous model in celestial mechanics, describing basically the motion of a satellite in the gravitational field created by two bodies orbiting each other. You can think of a satellite in the Sun-Earth gravitational field. And there's this good professor from Virginia Tech, is really outspoken. And he has, again, a YouTube channel, and I noted down this video. He has a big book with people from Caltech when he was doing his PhD in the early 2000s, and it's a really interesting book. So yeah, and here in the Markdown comment, yeah, it's basically linking to this video in my channel, and you can see also some links associated to the work. Yeah, shout out to Benjamin, he's German. Benjamin Boschmann from Telespazio, a company in Germany that helped me out with this work. The starting point is this quote by Zebehey, which was one of the main people in the Apollo program. He's originally from Hungary, but he was naturalized from the US. And he published this work in 1982, in which he challenged the assumption that celestial mechanics is made of deterministic systems. Not only because of inner uncertainty in observations, so it's not like you don't know where you are at the beginning of your simulation, but also because the actual model that's modeling the evolution of the state of your system, it's incomplete. You cannot take into account all the gravitational interactions in the solar system, let alone influences from other galaxies, stellar systems, that even if they're small, they're really many. And so there could be something to look into for that. So yeah, by the way, I don't know why I'm not seeing it. Maybe I'm zooming too much. Yeah, sorry. So yeah, I guess this is... again, there's a video of mine in which I'm reading a paper that was from this Victor Zebehey that is linked to this work and that inspired it. And as Zebehey says at the end of this paper, it was strongly inspired by Ilya Prigozhin, which was a Russian naturalized Belgian chemist, I guess, even though his book speaks like a physicist. Which worked a lot on irreversibility in complex systems and influenced almost philosophically. He published 2 works with this Belgian philosopher of science, challenging the usual deterministic perspective of classical mechanics, inspired by ideas from statistical mechanics and thermodynamics. And so this is kind of the big picture. Going in detail, in the more recent works, applied this perspective in celestial mechanics, and there've been this formalism coming from called the Fokker-Planck model from statistical mechanics, and then stochastic perturbations, random walk, which is a stochastic process, and many works. This one was by myself when I was doing my PhD, and this is from the author that I'm referencing, this guy from Yeshiva University, New York. So I won't bother you with the math, but the idea is that in this model, the evolution of the position and velocity of a spacecraft, you can think, is not just a deterministic function of its position with respect to the gravitational field, but there's also some kind of noise. Like this model is usually considered in thermodynamics, and this term is usually called the thermal bath, because you have so many particles hitting each other, and they make up some that you can't model on their own, and they make this. You can only treat them probabilistically, and so you use this calculus, which is called the Ito calculus, from a Japanese mathematician of the 50s, I guess. Even though, I mean, the original Einstein paper, for example, 1905, is already digging into these probabilistic models for dynamical systems. So yeah, I won't bother you with this math. I guess, yeah, I don't know how much to go in detail, but for sure it's interesting to see that I can use LaTeX expressions here, and but yeah, because of the probabilistic nature of these perturbations, when you apply a transformation in the reference frame, so when you apply a function on the state describing the differential equation given here, so when you have a function h of x, in which x is represented by this equation, the equation describing the evolution of y is not simply the transformation of the equations applied to x, but there's also another term popping up, because you see in this equation here there's this 1/2 something, and I'm not sure the audience, but I'll say that in usual calculus you can simply consider the Jacobian of the transformation, while here you also have to consider the Hessian, because you have this equation here on the left. Sorry, there's some noise from AMR Fauzi.
Yeah, I'm hearing that as well. Let me see if sorry about that.
Sure.
Yeah, thanks. So yeah, when you apply this transformation, it ends up that you need to consider also the Hessian, because the stochastic process has a variance which is proportional to the time, and so you have this equation, and it's not that dB squared is 0. So you have to consider higher order terms in the Taylor expansion of the function. And okay, then we go on to explain why this kind of model makes sense, and here I added some notes that I think are underlying the interesting potential of these nodes. Is that this was a note I took after presenting this work at a conference, and so this could be easily integrated in the paper in the future, and in a node you can kind of see the development of this work growing. So we gave a numerical rationale for this modeling, which I won't dig into. And then we showed the results. And so we started from this model, which was already existing, which models the motion of, let's think of the Earth around the Sun under the influence of a cloud of asteroids equally distributed in the solar system. And so you have these really small asteroids that one by one don't affect the motion of the Earth around the Sun, but if you consider their behavior overall, their influence on the Earth, because of the nature of the calculus outlined before, even if the mass of the single object is small, you have qualitatively different behaviors during long times. And so what happens is that quantities that are associated to the deterministic case would be conserved. In this generalized case, you have that they behave in a stochastic way. So the energy is defined here, and you see that it's following this equation. And the angular momentum, which is another quantity that's associated to a constant of motion in the deterministic case, is characterized by this evolution. And so numerically, this is shown here. And basically, you see that the orbit of the Earth around the Sun, in the deterministic case, it's always going. So the orbit is fixed, while in the stochastic case, it's moving and it's filling up the plane. And this is shown also in the quantity A, the energy. You see here, basically, it's constant. This is not horizontal because of numerical error. But you can see that in the stochastic case, the energy looks like the stock market. It's a stochastic process, and it looks like the price of Bitcoin in time, or of the DeSci node coin. I don't know in the future. So the same for the angular momentum. And it's interesting that here you cannot see the difference, but because here there is a term that's multiplying time, and here there's not. This means when you do a probabilistic analysis overall, and you just don't consider a single process, you get something like this, which means that an ensemble of solutions of this problem have an energy that in time, on average, increases, and it's also diffusing. So the standard deviation of this quantity is increasing in time, but also the mean, even though the stochastic perturbation has zero mean. And so this is kind of the point of the work. In the angular momentum case, instead, the mean is constant. And okay, it's not really constant because, again, on numerical error and limitations on the number of samples for the probabilistic analysis, but you can see that it's symmetric with respect to this line, while here we're going up. Then we digged a lot into the three-body problem, and we tried to find transformations that made sense physically. And we ended up, and there's no reason to dig more, with these equations, which, okay, it's not important, but it's just another problem. And you see, again, the same behavior. This time, this object is another quantity, which, again, it's describing something like the energy. And you can see that what we wanted to see was, okay, I should have underlined this before, but we wanted to show that this modeling could explain the causal emergence of what's called potentially hazardous asteroids. These asteroids that could potentially intersect the orbit of the Earth and hit it, but also explain the origin of the Moon, because the most trusted, let's say, model of the origin of the Moon is that there was a proto-Earth and a Mars-sized planet that impacted each other. This Mars-sized planet impacted the Earth, and from the impact there was the formation of a cloud that then coalesced, and this made up the Moon. And so the question is, where did this object come from? We try to argue in this modeling that because of the stronger part of this stochastic problem, there are equilibrium points in which mass could have aggregated. Once the mass was big enough, it started to stay there. But because then the stochastic perturbation due to all the cloud in the proto-solar system was perturbing it, this object was excited, and from staying fixed in this point, started to move, and then it did this. And then you propagate even more, and you do this. And then again, you start to move around in what's called a horseshoe orbit. You see this shape is like a horseshoe. This is the sun, and this is the Earth. And then you close the horseshoe, and if you keep going, at a certain point, you see that there's this breakout in the value of this quantity, and you see that the trajectory intersects the Earth. And so you have a probabilistic, you have a non-zero probability of an impact from an object starting still at this point and evolving in this stochastic field. Okay, this is a weird equation that we don't need to dig into. Again, this quantity is not only characterized by a diffusion in a probabilistic sense, but there's also the average going down, which means the energy is increasing. And so, yeah, as I said, we wanted to show a causal model to explain some of the behaviors in the evolution of what's called the Trojan population of asteroids. We wanted to argue for a reason making potentially hazardous asteroids emerge, and to explain the origin of the Moon. Yeah, I won't bother with this detail, but we ended up, and maybe again this could be a reason to consider nodes useful. Basically, this point was a justification for the abstract that was submitted. So the hope was to investigate stochastic resonances in this model, but then digging into it, we figured out that there was no space for this behavior, for this phenomenon. So we had to justify this here because the abstract contains that. In a node, if you could update the work, you could simply update the abstract and remove this sentence because there's no need then to have it here. For future words, yeah, we wanted to say something about numbers. So what's the actual probability of objects escaping a two-body system? What's the probability of the proto-moon impacting the Earth, and over which time span? This is a really mathematical question, not relevant. And this one is actually interesting because we are actually presenting this work, let me see, just this week for the Julia conference. Yeah, this one, it's not online yet, it's private. But what we did was to put together chaos theory and random motion, and we get these fancy animations. Okay, this is not as fancy, but you see this one now is super cool. And yeah, this was we wanted to investigate this, and we did it last month. That's it. Referenced by Prigogine that inspired this work. Really interesting readings, even from non-technical people. And here's my email. Here's my YouTube. I'm in the Discord, of course. And thanks.
Matteo, that was amazing.
Was it understandable? I hope I tried to distill it.
Yeah, that was really cool, Matthew. Thanks a lot for going so in depth with our product, and especially in alpha where things are still, under development and janky. I mean, I think this is the type of exploration you've been conducting here with your node is exactly what we want to do, right? We want to explore the abilities of the medium and find affordances that allow us to create, better scientific papers, more dynamic documents, more rich contextual information that allows us to understand perhaps, the broader conversations going on around the work, and also fostering reproducible results, such as having the ability to recreate graphs, using the code that's provided. So, I mean, all in all, I mean, that is super cool. This particular field you're in is so foreign to me, but it was really fun to listen to that, because physics, is a field that is very latex heavy. So that's the primary tool. So it was cool to see that you've actually made use of the latex integration into the annotations. So that was really cool in a meaningful way, which is, by the way, the first time this happens. So it's not just writing, random latex syntax. But yeah, I really appreciate. I mean, this is fantastic. I also love the idea of like linking to talks, linking to conversations and annotations. This is something which I think could have a lot of value when people are typically digging into a paper, to understand the broader conversations happening around it, which is something that are typically that have intermediates in academia, right? You have, let's say, respected colleagues that will write a preface to your work when you publish in a prestigious journal, right? And I think there's a lot of benefit of scientists, being able to go direct in conversations with others, and just to have the ability to refer to that. So I thought that was really, really cool. So thanks a lot for that presentation. And I'm really, really looking forward to understanding, all the ways you think we can make this better, especially coming from a physics community angle, which is a community that I personally have very little exposure to, and I'm really curious to hear what you think.
Yeah, thanks. No, I'm really. I was happy, as I said again in Saturday, having a space to discuss these ideas is really. It's really nice. So thanks for the work you're doing. As I said, I think the main. I mean, I don't know if you want to discuss now.
Yeah, I mean, I'm happy to open the conversation.
Okay, great. One point I mentioned Carla, and I think also to the sponsor of Saturday's event from Springer. To me, is this ability. I'm raising many. I mean, there are open points then to kind of connected to what Eric was saying about the intellectual property of DALL-E generated images based on actual images. So what I'm saying is, my hope is that one could have a GitHub-like object that's updated locally, both the LaTeX part, so the PDF part, the actual paper part, and the code and the data, that they're all standing alone can generate everything inside the paper. Maybe also something associated to, I don't know, Research Rabbit, Zenodo, all this stuff, helping you with the references.
Yeah. That I think we could do that for people that use latex, right? You have a latex compiler, and you can regenerate the paper. The broader issue, though, is that we want to make a solution that's generalizable enough so that people can use it without, let's say, this is a solution that only works for latex users, right? Which is just as said. So there's obviously like some important decisions we have to make in the terms of what's the direction of, like, what is there, like a community that's specific that we want to specifically appeal to, or do we want to keep it broader but then less optimized for specific communities? Having the ability to have an executable container. So this is something we're going to be implementing, where you can have reproducible containers like the ones from CodeOcean, or a Jupyter notebook, or a Finger container. That's something that we're going to be working on. And essentially, the ideal document, right, is when you think about it, is not like a PDF, right? The ideal document is like something like looks like a Juniper notebook, right? Ideally. or something like that. The problem with that, and I think a lot of the challenges with that, is that you can't really force scientists to completely change their workflow. Because whatever they publish, on DeSci Nodes or on DeSci in general, they're going to want to have published on archive, right, in their community platform, and that's going to be a PDF. They're going to want to publish it, they're going to want to send it to a conference and might be featured on the conference website. They're going to want to send it to a journal, American Physics Association or whatever names of the journals in that domain for publishing, right? So you want to have, we have to we're somewhat constrained the design space there, that we cannot change the way people do things too radically. What we can do, however, and I think this has been our philosophy from the start, is create a space where people can aggregate, right? They can aggregate all of these resources and they can connect it. So for example, you can take a graph or like a simulation where you have, your stochastic parameters, and you can say, hey, I'm going to link that graph with my executable container, and I can then regenerate those results by running the executable container to produce the graph, and then I will allow others to, for example, change the inputs and assumptions to generate different flavors of that graph, right? And the way we do it is we create a simple link on the PDF document itself to the specific executable file that is used to produce that figure. So that's the way we've been thinking about it. Now there's solutions out there that go really much deeper into that problem, like projects like Stencilla, for example, which are essentially purely HTML papers that actually run a Python notebook backend.
How's it called? Sorry.
Stencilla. And I mean, it's really impressive what they've done. The issue, though, is that it's incredibly time consuming for a scientist to do that, right? So when they have to, the time commitment, we have to be mindful of the time that people spend on publishing these objects, right? So I think there's a sweet spot, a sweet trade-off to find, and hopefully, we're going to get there with DeSci Nodes. But yeah, I mean, that's also why, we need to have these community conversations, these feedback sessions, these test sessions from a wide variety of different scientific backgrounds to see, the cases where it simply doesn't work and the cases where it works best, and how we can find a sweet spot between all of that. So yeah, I mean, just all of this to say thank you for exploring the product in such details. We have some really interesting updates that are going to come up in the coming weeks, and we're really excited to share some of those with you. You will have the possibility to upload videos on the format on the DeSci node, so they'll be saved on IPFS. It will probably still be served from the API of the video storage solution until we essentially create a reader and codec and all of that, which is non-trivial to do. But it will be possible to save videos. It will be possible to save raw data and all sorts of other artifacts. So looking forward to that.
Yeah, great. Thank you.
So with that being said, I guess the last little bit of our call, we wanted to quickly, I guess, for the next 20 minutes, kind of give an open forum for people to ask questions about DeSci Nodes, either from a design standpoint for Chris, or even potentially from a user standpoint for Matteo. Does anyone have questions they'd like to ask?
I think I have a quick question relating to peer review. So I think at one point I was talking to Chris maybe, and he was saying that you could like put out a bounty that might be able to allow someone to come in and peer review. Where is that in the development pipeline?
Oh yeah. So first, that's a great question. And first, we're building a base layer to create these research objects, and we are doing this with the architectural constraints that we are essentially devising a peer review system on top of it, right? So I think that's a lot of the design decisions that we're doing on this base layer are actually driven by a UX consideration, which is how to ensure that peer review is facilitated through UX, right? And typically when you think about something like validating a badge that says, hey, your data is available, Well, if you have in the interface the actual data, or you have a reproducible container to ascertain reproducibility, it makes proving these attributes, these facts about these objects, much, much easier for a peer reviewer. And you might ask, well, annotations would be great to add, commentary on Mattheo's work for a peer reviewer. And the answer to that is yes, it would be fantastic. And that's also why we've been devising the annotation systems and these types of features. And actually, this is probably where they bring the highest value. Now, you might also say that, if you're an author and you publish a paper, you don't just want anyone to come in and start adding annotations and commentary, and basically you feel like you're a graffiti wall, right? Nobody wants that. As a scientific author, you want to be, in control of the canonical version which you've authored. And so for this, to this end, the way we're thinking about it is essentially using the Git primitives of forking, pull request, merges, to essentially create a system where you can think of a scientific society that would conduct validation on a manuscript with its artifacts. And essentially, rather than, let's say, writing and having a permission from a top-down level, to write on the contract and to commit, we'd have a bottom-up system in which everyone, any entity, a person or a scientific community, can take a published node and fork it. They fork it, they create a copy. They're in control of that copy. They're in full control of that copy. They can now add annotations to it, add a peer review report component. They can perhaps draw this from a discourse forum or another source or markdown document. They can add all of that and essentially construct, this peer review report and conversations, linking from that report directly in the manuscript via annotations to paragraphs that perhaps need some work, to figures that need clarification, to results that don't exactly fit, within the scientific method in a very formal way. So you'd have the ability to essentially do that, all of that commentary, which is vital, which is the scientific validation process, verify these attributes, and then you can do a pull request, right? So you can pull request your fork, and if the authors of the canonical work accept the pull request, then it merges right on the canonical contract, which essentially now has this new version, right, which the authors would then, respond to, perhaps if they feel the need to respond, and add yet another new versions. Well, you might ask, well, now there's perhaps some issues with that, right? What happens if the authors of, let's say, some fraudulent paper don't, or something that's deeply flawed, right? They don't accept the pull request, right? That tells them essentially their work is deeply flawed. Well, you'd expect them to have, of course, an incentive to showcase their work in a positive light to the world and to deflect criticism, and that's true. So that's why in the UI itself, we will display the forks, right? So anyone can actually go and look at all the forks, and they'll see if there are respectable and reputable scientific communities that have commented, annotated, added peer review report to this piece of work. They'll also see whether the authors have accepted or rejected a pull request, right? So all of this, as long as everything is transparent and conveyed in a way that facilitates readability and understandability from the UI point of view, we can have the coexistence of both a permissionless system and a system that gives preserves control to the authors. And I think that's important because we're shifting the paradigm from the author takes their work and submits it to a scientific journal. So when you, in that act of submitting to a scientific journal, you're basically delegating your consent as an author to be reviewed and to be essentially having your work custodied by that scientific journal, which will produce what is called the version of record. That is the authoritative version of your work. So you delegate that permission. In DeSci, it doesn't work like this. It works in the opposite way. Essentially, you have an openly verifiable system where anyone can add a validation grant. Could be a funder, could be a biocorp, could be a private person. They can add a validation grant and earmark it to an ARC that has a certain reputation, to a scientific community with a certain track record of doing things right and essentially having a high level of rigor. That ARC can then take up that validation grant and say, yeah, we'll produce essentially a verification of the accuracy of perhaps the attributes of that research reports, of the reproducibility, all of these components and dimensions. And they will do that by forking the work. right? So they're never at any point without the author's consent that are owning the canonical version. There's not the possibility to essentially merge that object without their consent, right? And when you think about the signaling value, what does it mean if I, as an author, I accept, a pull request? Well, it means that I am in agreement, right? I am in agreement. I consent to what the ARC has done. I believe that they have added value to my work, right? That they have provided constructive criticism that I can address, and that it will make my work better. And so that's a strong signal, which is interesting. Of course, there's all sorts of angles around incentives that we need to explore very, very carefully here to make sure that the system sets the right incentives for all participants. And I think there's a very fine balance we have to walk here. But I just wanted to give you a preview on the way we're thinking about open verifiability, about the matters of consent, and about the idea of having truly open science that anyone can fork, can comment, can annotate on, can improve, can change, while preserving the control of the canonical object totally and entirely in the hands of the original authors.
Thank you. That was helpful and more than I anticipated. Also, do you have like a paper or like someplace where that's like written down so I can review?
No, well, we do, but it's not yet published, right? So it will happen with the beta release, which will happen in a month or two. So it's still there's still a lot of there's so much material we have to produce on this, and a lot of those design decisions, by the way, aren't set in stone. And I think that's a great occasion, to discuss with our community here and to just hear what you think, because we are at an early stage. We're building full speed along, but we very much welcome feedback and good ideas from the community.
And Ellie, just to tack onto that, all of these community calls do get posted, at least the recordings, the audio recordings, do get posted on YouTube. We're trying to make a more conscious effort to take some of the content from them and post it onto Twitter in a more short form, concise way. So as that happens with this call, I'll make sure to let you know.
Awesome, sweet. Thank you.
Can I jump on this, Chris, on what you said? I'm really interested in it's how do you say? Months ago, when I first discovered DeSci, basically, I went into it from entering from Radical, because my idea of DeSci was to use the Git protocol to have something like a Git commit history. I wanted to ask if this forking is like Git, so it's a continuous process, and the initial publication is free, let's say, like the archive. So you begin as in the archive, and then you're continuously open to being criticized. Because, the current peer review, as an example, the work I just discussed, it's built on another one, which is peer-reviewed, but it's patently wrong, and I discovered that in GitHub, basically. And of course, the paper out there is there. It's influencing the h-index of the author, while Chris Rokako's issue resolution number 25 in the GitHub repo is gonna disappear. And this, by the way, also goes for my papers. Like, I see a paper I wrote 3 years ago, I see a mistake or something not well written, and it's like, I don't know, going out of home without pants on, without noticing, and then you cannot go back to fix that. And
yep. It's a huge issue that when you post a correction to a publisher, it's a big shame for them. It's also a big shame for scientists. So people don't even send corrections over to publishers. I mean, if you've published, a couple dozen papers, you're aware of plenty of mistakes you've done, right? But the burden of like going to the publisher and saying, "Oh man, my table 3 here, there's a typo in the t value," right? It's a big story for a publisher. It's a substantial story. And so some publishers are actually extraordinarily slow at posting corrections, and it also looks bad, right? So people have the idea that published science is like somehow perfect, fixed in stone, everything's done. That's completely wrong, of course. So we are using Git primitives for interacting with these research objects. We are actually not, most of our data model is just built on diffs, right? So just like Git, it's essentially a great big diff engine that indexes the differences in the smart contract-based registry. And I think there's a lot of precedent and immense value to have a bit more of a Git-like inspired flow for producing scientific knowledge and manuscripts and artifacts. However, I don't think that we can just take Git and use Git to essentially make scientific papers and research objects because it has like much more features than what is required for science, and it also is essentially an solution that has quite a high barrier to entry for people that are not necessarily used to the Git workflow. So the question is, can we take the most essential functions of Git and the most high value functions of Git for science that would be, have the highest values for scientific work, and we could take those functions and make them part of our protocol and the way the system works, right? So we're trying to make essentially a trimmed down, extremely simplified version of Git that allows people to fork, to pull, to essentially commit, and to upgrade, to post new versions of their work, right? While keeping this idea of a canonical version, right, or like call it the master branch or whatever you want, that really canonical version which is under the control of the authors. So we're thinking, along these lines, essentially right now.
Great, thank you. And about the incentives for peer reviewing, why should I correct someone else's paper and not publish my own? Given that, is there the need to upgrade the metric that values a researcher, or how are you thinking about that?
Well, so why would a peer review someone else's work? I think what we're thinking about is a system that has open verifiability at its core, meaning that anyone can add a validation grant to a published piece of research. So imagine you have a preprint on arXiv, you have a button that says, hey, gather high quality expert peer review that, for example, could go beyond what the current system does, which is just, hey, I'm just checking the PDF, but actually check if, the artifacts have been posted, if there's, if the data has been posted in open access, if the data has restrained access, is there a path to accessing it? All of these minutiae details, which are extraordinarily important to create reproducible research and to improve the quality of the scientific record. I imagine you had a button to do that, and that the APC, right? So today you want to submit your work to, let's say, a mega journal like PLOS, which is on the cheap side. It's $1,500 that authors have to pay to have their work in open access, to go through that verification pipeline. Not a penny of that goes to peer reviewers or editors who are all working pro bono. It all goes to the journal ops. We can do better than that. If we can unbundle and remove some of the unnecessary functions of scientific journals and focus on the essential, which is scientific validation and verification and certification, then we can actually create a system that would capture that value and distribute it to the scientific contributors who have done the validation work. Or perhaps for more pro-social scientific communities, would go into a pot, and those scientific communities could set fellowships for their more junior members, which would give them an income complement, right? So that's the idea, is that we want to essentially flip the model on its head, have anyone have the ability to submit a validation grant, which is not a service agreement, it's a grant. It has no strings attached. ARCs essentially have to care for their own reputation and use this reputation as a signal to attract more of these grants, and have anyone with the ability to causally impact our graph of knowledge by doing that, right? And that, of course, brings up the question of consent. And this is where this idea of having Git primitives where you fork and you do a pull request and you can accept or reject comes in, right? Because it preserves the consent of authors in a way that they still feel in control of their work.
Right, thank you.
So does anyone else have questions about either design parameters within DeSci Nodes, the roadmap, some of the talks that were given either at Research Hub or in Paris, or the experience of creating a node from Matteo?
Yeah, I actually have a roadmap question. When am I going to be able to share my nodes with others who can just look at it?
Good question. I think so. So our idea, and this we could do this faster, of course, right? So I mean, it's actually a simple fix to do, to share it with others, and we might actually, if this is a popular request, we might actually do it and ship it out really fast. But the basic idea is that these nodes are private until they're committed on chain. And they're not necessarily private only to one person, because we want to have a collaborative ability, right? So the ability to invite your co-authors to co-edit and co-create that node and verify and sign off on it and all of that, right? So the idea is that they're private by default. You can invite your co-authors, they accept the invitation, they now can see it, they can edit the research object, and when everyone's good with it, you commit it on chain and now becomes a public access artifact. However, for demonstration purposes or for having the ability to share it with friends to get feedback earlier, we could very easily flip the permission switch here and allow, have a link similar to Google Drive link where people could access that and essentially see how it works. So if that's a popular feature that people would want fast, we can actually ship it faster. In the case of the on-chain indexing on testnet, that's something I see happening essentially in September.
Okay, cool. Yeah, I think it would be cool if just to be able to have, I mean, I don't think, yeah, just to be able to share a link with someone who can then look at the node in the UI would be really cool and would also probably help spreading the word.
Yeah, I like that. I'm taking a careful note on this, and I'll consider it carefully. I think that might be a really good idea for spreading the word and getting some more feedback.
Yeah.
Yep, it's definitely one that's been requested by quite a few people. So we have 5 minutes left on the call, which is probably time for about one last question. Does anyone have anything they want to ask? Okay, well, I'm going to go ahead and assume silence is golden. Chris, do you have anything else you want to add before we switch over to coffee house mode?
No, thanks a lot for again, gratitude, Matthew. Thank you for demonstrating your node. I think you've really did a great job exploring the set of features that are capable and also bringing up to our attention what needs more thoughts and more priorities. So thanks a lot for that. I really appreciate it.
Sure, thank you. Pleasure. Really a pleasure. Thanks.
And serious shout out to Matteo for rearranging his entire travel plans to be here and present them.
Yes. Let me share the screen for sorry, turn on the camera for a second so you can see the airport.
Oh Lord. Wow, that is dedication. Okay. Well, if that's the case, thank you everyone for joining. Much appreciated. We'll be posting quite a few calls from this past week on YouTube in the near future, whether it's a community call, whether it's a talk that we've given recently, or some of the work that Matteo has been doing around creating nodes. Next week, we're going to be looking at Ian Hayes' node around the general index and some of the work that he's been doing actually explaining the larger project and linking back to code in an understandable way. So I'm excited to see that one as well. Thank you to all, and have a wonderful day. If you want to stay for a little bit, we have Coffee House starting in a little bit just to hang out and chat and get to know each other.